Hello, friends. Welcome. I'm really glad you're here. To begin, I'd love to hear where you're watching from and what the clock says for you right now. It's amazing to see people gathering here from so many places at all sorts of hours. Thank you also to those who've subscribed and supported the channel by liking the videos. It means more than you know, and it helps others find their way here too. If you have suggestions for future topics, please share them in the comments. Now let's begin. Chapter 1. Understanding Quantum Vacuum Concepts. In the realm of physics, the quantum vacuum emerges as a fundamental concept that challenges our traditional perceptions of empty space. At first glance, one might envision a vacuum as a mere void, an absence of matter and energy. Yet the quantum vacuum is anything but empty. It is a rich tapestry of fluctuating energies, where the very fabric of reality pulsates with potential. Understanding this concept is essential, for it underpins much of modern physics and offers profound insights into the nature of the universe. Historically, the idea of empty space has undergone a transformation. Ancient philosophers viewed the void as a simple absence, a barren expanse devoid of substance. This notion persisted for centuries, influencing scientific thought. However, as our understanding of the universe deepened, so too did our comprehension of what it means for space to be empty. The advent of quantum mechanics in the early 20th century marked a pivotal shift. It revealed that what we perceive as a void is, in fact, teeming with activity at the quantum level. This redefinition of emptiness reshaped not only physics, but also our philosophical outlook on existence itself. At the heart of this reimagining lies the concept of vacuum fluctuations. Picture, if you will, a calm lake, appearing still on the surface, yet beneath, currents swirl and eddy. In much the same way, the quantum vacuum is filled with transient fluctuations. These fluctuations are not mere anomalies. They give rise to what are known as virtual particles. These particles are fleeting, popping into existence and then vanishing almost instantaneously. Their presence a testament to the dynamic nature of the vacuum. The significance of virtual particles cannot be overstated. Renowned physicist Richard Feynman once remarked, "The world is made of stories, not atoms." In this context, the stories unfold within the quantum vacuum, where virtual particles engage in a cosmic ballet of creation and annihilation. They are not tangible entities in the classical sense, yet they exert real effects on the physical world, influencing everything from the forces that bind atoms together to the very fabric of space-time. Key figures in the development of quantum field theory have illuminated the complexities of these concepts. Pioneers like Paul Dirac and Wolfgang Pauli laid the groundwork for our understanding of particle physics within a quantum framework. Dirac's equation, which elegantly combined quantum mechanics and relativity, hinted at the existence of antimatter and opened new doors to understanding the vacuum. Pauli's exclusion principle further clarified the behavior of particles in the presence of the vacuum, establishing the rules that govern their interactions. Imagine a world where every fleeting moment is rife with possibility, where the vacuum serves as a stage for endless interactions. This is the essence of quantum field theory, where fields permeate all of space and particles are merely excitations of these fields. In this view, the vacuum is not just an absence. It is a vibrant medium through which particles communicate and interact. As we delve deeper, we must consider the implications of these concepts. How does this understanding of the quantum vacuum reshape our view of reality? It suggests that emptiness is a source of creativity and energy, a dynamic interplay of forces rather than a sterile void. The universe, in all its complexity, is painted with the brush of quantum fluctuations, each stroke revealing deeper layers of existence. The journey into the quantum vacuum does not merely satisfy intellectual curiosity. It invites us to reflect on the nature of our own existence. Are we not in some ways similar to the virtual particles that flicker in and out of existence? Do we not also experience moments of profound connection and isolation, of presence and absence? This contemplation can foster a sense of wonder, grounding us in the idea that what we perceive as empty space is alive with potential. As we explore these ideas, we find that the quantum vacuum becomes a mirror reflecting the intricate relationships that bind the cosmos. It encourages us to embrace uncertainty, to revel in the mysteries that science seeks to unravel. The stories that unfold within the quantum vacuum are as much about the universe as they are about us, challenging our perceptions and inviting us to ponder the very nature of reality. In this vast landscape of understanding, the quantum vacuum stands as a testament to the beauty of scientific inquiry. It reminds us that the pursuit of knowledge is an ongoing journey, one that continually reshapes our understanding of the universe and our place within it. As we continue to explore this remarkable concept, we uncover layers of meaning that resonate with our own experiences, drawing us closer to the essence of existence itself. The quantum vacuum, once dismissed as empty, reveals itself as a boundless realm of potential, inviting us to dive deeper into the mysteries that lie ahead. The quantum vacuum, far from being a mere void, serves as a dynamic ground from which the universe springs forth. It is a realm where the laws of classical physics seem to dissolve, giving way to the peculiar behaviors dictated by quantum mechanics. This realization invites us to ponder, what does it mean for something to exist in a state of perpetual flux? Can we truly grasp the implications of a universe where particles can emerge from nothingness, only to vanish again in a fleeting moment? In the early 20th century, scientists began to unravel the mysteries of this enigmatic vacuum. One of the key figures in this revolution was Niels Bohr, who famously remarked, "Everything we call real is made of things that cannot be regarded as real." This insight nudges us to reconsider the very fabric of reality. As we delve deeper into quantum field theory, we find that particles are not the fundamental building blocks of the universe. Instead, they are excitations of underlying fields that permeate all of space. This perspective shifts our understanding of existence from a static state to a vibrant interplay of energies, constantly in motion. The concept of vacuum fluctuations lies at the heart of this understanding. Imagine a serene lake, its surface seemingly undisturbed. Yet beneath, currents swirl and eddy, shaping the depths unseen. Similarly, the quantum vacuum is teeming with virtual particles, ephemeral entities that pop into existence, interact, and then dissipate. They are a testament to the energy that vibrates within the fabric of space-time, revealing that even in the absence of matter, activity persists. How does one visualize such a phenomenon? Picture a field of wildflowers, each bloom representing a different virtual particle. They spring up, bright and vibrant, only to be replaced by others, creating a beautiful and transient landscape. The energy of the vacuum creates a tapestry of possibilities, allowing for the emergence of particles that give rise to the rich diversity we observe in the universe today. The implications of these fluctuations extend far beyond theoretical musings. They offer a lens through which we can observe the nature of forces like electromagnetism and gravity. The vacuum is not merely an empty stage, but a crucial player in the grand performance of cosmic events. It is the unseen mediator that shapes the interactions of particles, allowing them to dance together in a complex choreography of forces. One remarkable figure in this exploration of the quantum vacuum is Richard Feynman, who famously illustrated quantum electrodynamics with his diagrams of particle interactions. He expressed, "The imagination of nature is far greater than the imagination of man." Feynman's work highlighted how virtual particles, although fleeting, can exert real influence, such as in the phenomenon of the Casimir effect. This effect serves as a tangible demonstration of vacuum energy, where two uncharged plates placed in a vacuum experience an attractive force due to the suppression of virtual particles between them. This fascinating interplay between the vacuum and particles challenges our conventional understanding of emptiness. It raises questions about the very nature of existence itself. If the vacuum can give rise to particles, what does that imply about the origins of the universe? Can the act of observation influence the behavior of these ephemeral particles? These questions echo through the halls of scientific inquiry, inviting us to consider the profound connection between consciousness and the cosmos. As we traverse this landscape of quantum possibilities, we find ourselves contemplating the role of key figures and theories that have shaped our understanding. The groundwork laid by pioneers such as Albert Einstein, who sought to unify the forces of nature, continues to inspire contemporary thought. Einstein's assertion that God does not play dice with the universe reflects a longing for order within the apparent chaos of quantum mechanics. Yet, in the heart of the quantum vacuum, we encounter a world where randomness is not merely a flaw, but a fundamental aspect of existence. The quantum vacuum also invites us to reflect on the significance of uncertainty. Heisenberg's uncertainty principle posits that we cannot simultaneously know both the position and momentum of a particle with absolute precision. This principle invites us to embrace the unknown, to find beauty in ambiguity. What if this uncertainty is not a source of frustration, but rather an invitation to explore new realms of possibility? Could it be that the limitations we perceive in our understanding are simply reflections of our current state of awareness? As we delve into the nuances of quantum field theory, we encounter the profound realization that the vacuum is a fountain of creativity, where particles are born and annihilated in a continuous cycle. This cycle mirrors the rhythms of life itself, where beginnings and endings are interwoven in an intricate tapestry of existence. Each moment holds the potential for transformation, urging us to reflect on our own journeys of growth and change. Imagine standing in a vast field, the wind whispering secrets of the universe as it rustles through the grass. Each blade, each whisper, carries with it the energy of the quantum vacuum, vibrating with the potential for new beginnings. In this moment, we are reminded that we are not separate from the universe, but rather intricately connected to its fabric. The quantum vacuum is a reminder that we are part of a grander design, woven into the very essence of reality. As we continue our exploration, we find ourselves drawn into the depths of this fascinating concept. The vacuum, once thought to be an empty expanse, reveals itself as a dynamic environment rich with possibilities. It encourages us to embrace the unknown, to seek knowledge not as a destination, but as an ongoing journey of discovery. With each layer of understanding we peel back, we come closer to grasping the profound implications of the quantum vacuum. It is a realm where the boundaries between the tangible and the intangible blur, where the very act of observation shapes the outcome of events. In this fluid landscape, we are invited to consider not just the nature of particles and forces, but also our relationship with the universe itself. As we linger in this realm of contemplation, we recognize that the quantum vacuum is a mirror reflecting our own existence. It teaches us that even in moments of solitude, we are surrounded by potential. The universe is alive, pulsating with energy and possibility, urging us to engage with the mysteries that lie ahead. What stories will unfold as we continue to explore the depths of the quantum vacuum? What insights await us in the shadows of uncertainty? The journey is far from over, and with each step we draw closer to unveiling the wonders that lie beneath the surface of what we perceive as reality. As we stand at the intersection of understanding and mystery, the quantum vacuum beckons us to consider the very nature of emptiness itself. It challenges our preconceived notions, urging us to explore how classical interpretations of space contrast with the rich tapestry woven by quantum mechanics. In this next chapter, we will delve deeper into these distinctions, unraveling the properties of vacuum in classical physics, while uncovering how quantum insights reshape our perception of what it means for space to be empty. The journey into the heart of this enigmatic concept promises to reveal not just the mechanics of the universe, but also the profound implications for our understanding of reality itself. With each revelation, we will edge closer to grasping the role of zero-point energy, illuminating the vibrant dynamics that exist even in the void. Chapter 2. The nature of empty space in physics. Empty space, often perceived as a mere backdrop to the vibrant world of matter and energy, holds secrets that challenge our understanding of reality. In quantum field theory, this emptiness transforms into a canvas painted with the colors of possibility, where the very nature of space bends and shifts. Picture a vast, quiet expanse, devoid of tangible presence, yet teeming with unseen forces and potentials. This is the realm of the quantum vacuum, where the classical ideas of space give way to a more intricate and dynamic understanding. Classical physics, with its structured laws and predictable outcomes, presents space as an empty void. This vacuum is defined by simplicity, characterized by the absence of matter and energy. It is a stage upon which the universe plays out its grand narrative. Yet within this classical framework, the properties of vacuum remain somewhat limited. It is a place where no particles exist, where silence reigns and nothing happens. The vacuum is merely an absence, a container of sorts, waiting for the arrival of matter to fill it. But as we delve into the quantum realm, a fascinating transformation occurs. Quantum mechanics reshapes our perception of this emptiness, challenging the very foundation of what we believe space to be. Imagine, for a moment, that the vacuum is not a barren wasteland, but a bubbling cauldron of potential. In this world, even the emptiest of spaces is alive with activity. Quantum fluctuations emerge, momentarily creating and annihilating particles, as if the vacuum itself is bursting forth with energy. Renowned physicist Richard Feynman once eloquently stated, "The most important thing to know about the universe is that it is full of empty space." Yet this emptiness is deceptive. It is filled with an unseen energy, a backdrop for the ceaseless play of particles and waves, each vying for existence. The classical understanding of space, with its neatly defined borders, becomes a mere shadow as we embrace the quantum view. At the heart of this quantum revolution lies the concept of zero-point energy. In the classical world, one might assume that the absence of energy means a complete lack of activity. However, quantum mechanics introduces the idea that even in its lowest energy state, the vacuum is not devoid of energy. Instead, it pulsates with zero-point energy, a residual energy that exists even when all familiar forces seem to vanish. Imagine a tranquil lake on a still day, where the surface appears smooth and undisturbed. Yet beneath, the currents swirl and shift, creating a hidden world of movement. This is akin to the quantum vacuum, where zero-point energy lies beneath the surface of perceived stillness. It is a constant reminder that emptiness, in the quantum sense, is anything but empty. The implications of zero-point energy are profound. It suggests that the vacuum is not just a passive void, but an active participant in the universe's grand design. This energy can lead to phenomena such as the Casimir effect, where two uncharged plates placed in a vacuum experience an attractive force due to the fluctuations of the vacuum energy between them. This subtle yet powerful interaction reveals just how vibrant the quantum vacuum truly is. As we explore the nature of empty space in physics, we are invited to reconsider our ideas about reality. The classical and quantum understandings of space are not merely two sides of a coin, but rather a complex interplay that shapes our universe in ways we are only beginning to comprehend. The vacuum is no longer just a container for matter. It is a dynamic field of potentiality, rich with energy and life. In this new light, we recognize that the very fabric of our universe is woven from the threads of this quantum vacuum. It beckons us to look deeper, to peel back the layers of conventional wisdom, and embrace the mysteries that lie within. What does it mean for us to acknowledge that the emptiness around us is full of unseen energy? How does this knowledge reshape our relationship with the universe? As we reflect on these questions, we find ourselves at the threshold of a new understanding, one that invites curiosity and wonder. The nature of empty space, once thought to be simple and unchanging, reveals itself as a profound and intricate phenomenon, waiting to unfold its secrets to those willing to explore. As we delve further into the nature of empty space, we encounter the concept of vacuum in classical physics. Traditionally, the vacuum was perceived as an absence, a barren expanse devoid of matter. It was a realm where no atoms or particles resided, a simplistic view that aligned with the everyday experiences of the macroscopic world. Yet, even in this classical interpretation, the vacuum held certain properties. It was understood to possess a pressure, albeit minuscule, and to act as a medium through which light could travel, as per the wave theory of light. Imagine standing in a serene open field, the air around you feeling both tangible and yet invisible. This classical vacuum, while seemingly void, was the canvas upon which the strokes of matter could manifest. The properties of this vacuum allowed the propagation of sound, the movement of celestial bodies, and the subtle interactions of forces. It was a backdrop to existence, a silent witness to the unfolding drama of the universe. Yet, as we transition into the realm of quantum mechanics, our understanding of this empty space begins to transform dramatically. Quantum field theory introduces a profound shift in perspective. Here, emptiness is not merely a lack of substance. It is brimming with potential. Space becomes a complex arena where fields permeate and particles flicker in and out of existence, revealing a richness previously unimagined. One might ponder, how can nothing give rise to something? This question lies at the heart of quantum mechanics. The vacuum state, in its most fundamental description, is not a static void, but a dynamic entity where various fields interact and fluctuate. As physicist Richard Feynman eloquently stated, "The world is made of waves and particles, and the vacuum is a sea of possibility." These fluctuations are not just theoretical musings. They manifest in the physical world, influencing everything from the behavior of fundamental particles to the structure of the cosmos. At the very core of quantum mechanics is the concept of zero-point energy, a phenomenon that illustrates the vibrancy of the vacuum. Even in a perfect vacuum, an idealized state with no particles present, quantum mechanics predicts that there exists a residual energy. This energy arises from the inherent uncertainty associated with the position and momentum of particles, a principle beautifully encapsulated in Heisenberg's uncertainty principle. Consider for a moment a perfectly still lake, its surface unbroken, yet beneath the surface, the water is alive with currents and eddies, invisible to the eye but undeniably present. Zero-point energy is akin to those hidden motions, a reminder that even in silence, there is a hum of activity. This energy is not merely a curiosity. It has profound implications for our understanding of the universe. In quantum field theory, particles can be thought of as excitations of underlying fields. When we talk about the vacuum, we refer to a state where all these fields fluctuate, giving rise to virtual particles, brief, ephemeral bursts of energy that pop into existence and vanish almost instantaneously. These fleeting entities are responsible for mediating forces between particles, a delicate ballet of creation and annihilation that plays out on the quantum stage. What might this mean for our everyday lives? As we acknowledge the presence of zero-point energy, we begin to see the potential for harnessing this latent power. Could it hold the key to revolutionary technologies, perhaps even clean energy sources? The possibilities are tantalizing, inviting us to dream of a future where the energy of the vacuum could be tapped, transforming our relationship with energy itself. As we explore these concepts, the interplay between classical and quantum views of empty space invites us to reflect on the nature of existence itself. What does it mean to occupy a universe that thrives in emptiness? The ancient philosopher Lao Tzu once said, "Nature does not hurry, yet everything is accomplished." In this spirit, we are reminded that the vacuum, often dismissed as mere nothingness, is an essential player in the grand scheme of creation and destruction. To truly grasp the significance of empty space in physics, one must embrace the paradox it presents. The vacuum is both a source of nothingness and a wellspring of energy. It is a space that, though seemingly devoid of substance, brims with the potential for existence. The journey through this understanding reshapes our perception of reality, urging us to see the unseen and to appreciate the intricate dance of forces that shape our universe. As we stand on the brink of this new understanding, one cannot help but wonder about the implications that arise from the quantum view of space. How does recognizing the vacuum as a dynamic field change our perspective on the cosmos? It encourages us to envision a universe in constant flux, where nothing is truly still, and where every particle is a whisper of energy echoing through the fabric of space. The contemplation of such ideas invites us to pause and reflect. Picture the vast emptiness of the cosmos, a canvas painted with the hues of stars and galaxies. Yet, beyond this visual grandeur lies a hidden world of quantum fluctuations, a realm rich with possibilities. It beckons us to ask deeper questions, to explore the boundaries of our understanding, and to marvel at the mysteries yet to be uncovered. As we delve deeper into the nature of empty space, we encounter the profound implications of vacuum energy in the context of cosmology. The concept of a quantum vacuum extends far beyond the microcosm of particle physics, influencing the very evolution of the universe itself. In the early moments after the Big Bang, the vacuum played a crucial role in shaping the cosmos, acting as a catalyst for the expansion that followed. Imagine the universe as a bubbling cauldron of energy, where the vacuum is not merely a backdrop but an active participant in the unfolding drama of creation. This perspective offers a glimpse into the intricate mechanisms that govern cosmic inflation, a period of rapid expansion that set the stage for the universe we know today. The vacuum energy in this context is thought to have driven the inflationary phase, providing the necessary push to stretch space itself. As we ponder the nature of this vacuum energy, we cannot ignore its connection to dark energy, the enigmatic force that appears to be accelerating the expansion of the universe. Dark energy, which constitutes a significant portion of the universe's energy density, is intrinsically linked to our understanding of the quantum vacuum. This connection invites us to explore the profound implications for the future of the cosmos. What lies ahead as we continue to unravel these mysteries? The interplay between vacuum energy and dark energy suggests that the very fabric of space is not static, but a dynamic entity that evolves over time. Our understanding of the vacuum, once confined to the realms of theoretical physics, now invites us to consider the grand tapestry of cosmic evolution, where every fluctuation, every burst of energy contributes to the story of existence. In this journey, we are reminded that the nature of empty space is not merely an abstract concept confined to textbooks or laboratories. It is a living, breathing aspect of our universe, a reminder that the unseen forces at play are as vital as the visible stars that illuminate our nights. As we delve into this cosmic dance, we find ourselves not just as observers, but as participants in a grand adventure, one that invites us to question, to wonder, and to embrace the profound beauty of the unknown. As we stand on the brink of understanding the dynamic interplay between vacuum energy and dark energy, we are drawn deeper into the enigmatic realm of quantum mechanics. Here, the very nature of empty space reveals itself as a stage for the emergence of virtual particles, fleeting entities that dance in and out of existence. These quantum fluctuations not only challenge our perceptions of reality, but also hold the key to unlocking the mysteries of the universe. In the next chapter, we will explore these elusive particles, examining the implications of their existence and the experimental evidence that brings them to light. Prepare to delve into the captivating world of quantum fluctuations, where the fabric of reality itself seems to shimmer with possibilities yet to be discovered. Chapter 3. Quantum Fluctuations, the Dance of Virtual Particles. In the depths of the quantum realm, where the fabric of reality appears to tremble, lies a phenomenon that beckons our curiosity: quantum fluctuations. Picture a vast ocean of nothingness, where the very absence of matter is teeming with energy. This is the quantum vacuum, not merely an empty void, but a dynamic stage where invisible actors play their fleeting roles. These actors are the virtual particles, ephemeral entities that emerge momentarily from the vacuum, blurring the boundaries of existence. Quantum fluctuations are the spontaneous variations in energy that arise in this quantum vacuum. They are not mere theoretical constructs. They are the whispers of energy that ripple through the universe, demonstrating that even the emptiest space is alive with activity. Imagine for a moment a still lake, its surface perfectly calm. Now envision the gentle breeze that stirs the water, creating ripples that distort its tranquility. This is akin to how quantum fluctuations disrupt the stillness of the vacuum, manifesting as fleeting bursts of energy. The implications of these fluctuations are profound. They challenge our understanding of reality and the nature of existence itself. As physicist Richard Feynman once said, "The thing that makes quantum mechanics so strange is that it does not work in the way that we expect things to work." This strangeness is at the heart of quantum fluctuations, where particles can seemingly pop in and out of existence, defying our classical intuitions. To better grasp this concept, consider the virtual particles that materialize from the vacuum. These particles, while they cannot be directly observed, exist momentarily before annihilating each other, vanishing back into the fabric of nothingness. They are like whispers of possibility, reminding us that existence is not merely about what is visible, but also about what can emerge from the unseen depths of the universe. Experimental evidence supports the existence of these fluctuations. One of the most compelling pieces of evidence comes from the phenomenon known as the Casimir effect. Picture two uncharged metal plates, placed incredibly close together in a vacuum. The virtual particles between these plates create a pressure that pushes them together, demonstrating that the vacuum is not empty but filled with energy fluctuations. This experiment elegantly illustrates how quantum fluctuations can have tangible effects on the physical world. The impact of these fluctuations extends beyond the confines of a laboratory. They play a vital role in various physical phenomena, influencing everything from the stability of atoms to the behavior of black holes. The very fabric of our universe is interwoven with these fluctuations, shaping the cosmos in ways we are only beginning to understand. Consider the process of particle creation, where energy from fluctuations can give rise to real particles. This event occurs in high-energy environments, such as during the collision of particles in accelerators. In essence, virtual particles provide a bridge between the realms of possibility and reality, illustrating how energy can transmute into matter. Moreover, the dance of virtual particles does not cease with their brief existence. They contribute to the forces that govern our universe, influencing the interactions between particles and the fundamental forces of nature. This interplay is a reminder that beneath every solid structure lies an intricate ballet of energy and matter, a constant flux that defines our reality. As we delve deeper into the nature of quantum fluctuations, we might find ourselves pondering the very essence of existence. What does it mean for something to emerge from nothing? How does the interplay of these fleeting particles shape the universe as we know it? Such questions echo through the corridors of science, inviting us to explore the mysteries that lie beyond our current understanding. In this exploration, we can appreciate that quantum fluctuations are not merely anomalies. They are the heartbeat of the universe, a reminder of the complexity and beauty that exists within the unseen. The world around us, with its apparent solidity, is underpinned by a vibrant tapestry of virtual particles, each one a fleeting reminder of the potential that exists in the quantum realm. As we reflect on these quantum phenomena, let us carry with us the realization that the universe is a wondrous place, where even the absence of substance is filled with possibility. The dance of virtual particles continues, a subtle yet powerful force that shapes the very essence of our reality. As we turn our attention to the implications of quantum fluctuations, we can begin to understand how they subtly mold the universe around us. Imagine a vast, silent ocean, where each wave is a momentary manifestation of energy, rising and falling in a rhythm that is fundamental yet often overlooked. These fluctuations permeate the fabric of space-time, creating ripples that can influence everything, from the formation of galaxies to the behavior of atoms. The concept of virtual particles is intricately tied to the vacuum of space. This vacuum, often mistakenly perceived as empty, is a seething cauldron of activity. The energy contained within this vacuum gives rise to virtual particles, which appear and disappear in a fleeting existence, governed by the principles of quantum mechanics. As Richard Feynman, one of the pioneers of quantum physics, once said, "The universe is not only queerer than we suppose, but queerer than we can suppose." His words resonate deeply when we consider the elusive nature of these particles and the profound impact they can have on the universe. Experimental evidence supporting the existence of quantum fluctuations has emerged from various avenues of research. One significant example is the phenomenon of the Casimir effect, where two uncharged plates placed in a vacuum experience an attractive force due to the suppression of virtual particles between them. This effect serves as a tangible demonstration of the underlying quantum fluctuations at play, allowing scientists to feel the pulse of the vacuum in a way that can be measured. The mere act of bringing those plates together reveals how the vacuum is not an absence, but rather a dynamic entity filled with potential. As we explore further, we find that virtual particles are not merely theoretical constructs, they play a crucial role in physical phenomena. Consider the process of particle-antiparticle creation, a delicate ballet fueled by quantum fluctuations. These fleeting pairs emerge from the vacuum, only to annihilate each other in a flash of energy. This process highlights an essential principle of quantum mechanics. Energy can spontaneously transition into mass, even if only for the briefest of moments. The transient nature of these particles reminds us that even the most stable of structures in our universe depend on this cosmic symphony of creation and destruction. The implications of quantum fluctuations extend beyond particle physics. They ripple through various aspects of our understanding of the universe. In cosmology, for example, these fluctuations are thought to have seeded the formation of large-scale structures like galaxies during the early moments of the universe. Imagine the vast cosmos, an expanse of stars and galaxies, all shaped by the invisible hands of quantum mechanics. Each galaxy, a testament to the fluctuations that occurred during the birth of the universe, tells a story of potential that was realized through the dance of virtual particles. As we ponder these cosmic connections, we may wonder how such minuscule fluctuations can lead to grand structures on a cosmic scale. It is here that we encounter the profound interconnectedness of all things. The very fabric of reality is woven together by the interactions of these ephemeral particles, a reminder that even the smallest of actions can lead to monumental consequences. The words of physicist John Wheeler echo in our minds, it from bit. He proposed that the universe is fundamentally rooted in information, suggesting that the fluctuations of the vacuum might hold the key to understanding the very nature of existence. In our quest to comprehend the implications of these fluctuations, we should also consider how they impact our day-to-day reality. Quantum fluctuations influence the behavior of atoms, the building blocks of matter. As these particles emerge and vanish, they affect the forces that bind atoms together, ultimately shaping everything we perceive. The way molecules interact, the properties of materials, and even the stability of chemical reactions are all intricately linked to this unseen realm. The gentle whisper of virtual particles underpins the very essence of matter, illustrating how the grand tapestry of existence is interwoven with threads of quantum uncertainty. While the scientific community has made significant strides in understanding quantum fluctuations, many questions remain. What lies beyond our current knowledge? What mysteries are yet to be unveiled? As we reflect on these uncertainties, we are reminded of the beauty of scientific inquiry. The journey of discovery is filled with wonder, as each answer leads to new questions and deeper insights into the nature of reality. The words of Albert Einstein resonate. The important thing is not to stop questioning. Curiosity has its own reason for existence. As we delve deeper into the fabric of quantum fluctuations, we begin to appreciate the delicate balance between chaos and order. These fluctuations manifest in various phenomena, from the behavior of superfluid helium to the properties of superconductors. In these states, the effects of quantum fluctuations become vividly apparent, revealing the extraordinary capabilities of matter when influenced by the dance of virtual particles. Picture a superfluid, flowing with an effortless grace, defying conventional understanding. It serves as a reminder that the world operates not merely on the principles of classical physics, but is also shaped by the enigmatic forces of quantum mechanics. The implications of quantum fluctuations extend to our understanding of time and space themselves. As we contemplate the vacuum, we must ask ourselves, can the very nature of time be influenced by these ephemeral particles? Some theorists suggest that the fluctuations of the vacuum could hold secrets to the fabric of space-time, potentially leading to a deeper understanding of gravity and the fundamental forces of nature. This interplay between the quantum realm and the macroscopic universe invites us to explore the uncharted territories of physics. Let us take a moment to visualize this dance of energy and matter. Imagine standing in a serene meadow, surrounded by the gentle rustle of leaves and the soft hum of life. Each sound, each movement, is a reflection of the intricate interplay of forces at work. In the same way, quantum fluctuations breathe life into the universe, creating a backdrop of energy that supports the existence of everything we hold dear. As we observe the world around us, we may find it challenging to reconcile the tangible with the intangible, the visible with the invisible. Yet, just as the gentle breeze carries the scent of flowers, so too do quantum fluctuations weave through the fabric of reality, connecting every aspect of existence. The more we explore these phenomena, the more we realize that the universe is not merely a collection of isolated entities, but a vast, interconnected web of energy and information. In this expansive tapestry of existence, virtual particles serve as a reminder of the potential that lies within the void. They beckon us to embrace the unknown, to find beauty in uncertainty, and to appreciate the delicate balance that sustains our reality. As we continue to explore the depths of quantum fluctuations, we open ourselves to new possibilities, inviting wonder and curiosity into our understanding of the universe. The dance of virtual particles persists, a gentle reminder that even in silence, there lies a symphony of creation waiting to be discovered. As we reflect on the intricate interplay of quantum fluctuations and their profound implications for our understanding of the universe, we stand at the threshold of a remarkable discovery, the Casimir effect. This phenomenon serves as a tangible manifestation of vacuum energy, offering us a unique lens through which to examine the very essence of emptiness. In the following chapter, we will delve into the origins of the Casimir effect, exploring the experimental setups that brought this elusive concept into the light of observation. By examining its implications for quantum theory and cosmology, we will uncover how this seemingly abstract principle shapes our comprehension of the universe's structure and energy. Join me as we venture deeper into this captivating realm, where the void reveals its secrets and invites us to question the nature of reality itself. Chapter 4. Casimir Effect, Measuring Vacuum Energy. Imagine a world where the very fabric of space-time is not merely a stage for events to unfold, but a dynamic, shifting entity filled with possibilities. This concept, often referred to as quantum foam, serves as the foundation for understanding phenomena that challenge our traditional views of reality. At incredibly small scales, space-time is not smooth and continuous. Rather, it is a frothy sea of fluctuations, where virtual particles spontaneously emerge and vanish. This peculiar aspect of the universe opens a doorway to deeper insights into the nature of existence itself. The Casimir effect, a captivating manifestation of this phenomenon, was first predicted in the mid-20th century by the Dutch physicist Hendrik Casimir. He proposed that two uncharged parallel plates placed in a vacuum would experience a force drawing them together, due to the energy fluctuations within the quantum vacuum. To grasp this, consider the idea that while we perceive a vacuum as empty space, it is teeming with activity at microscopic levels. As Casimir eloquently stated, "Nothing is more real than the unreal." The very act of placing two plates in a vacuum alters the energy density between them, creating a pressure that pushes the plates together. Experimental setups to demonstrate the Casimir effect are as intriguing as the theory itself. In one notable experiment, researchers utilized finely machined plates spaced mere nanometers apart. When they measured the force between these plates, they found a significant attraction, confirming Casimir's prediction. These experiments, often conducted with high precision and temperature-controlled environments, reveal the subtle yet profound influence of vacuum energy. Imagine the meticulousness required. As scientists create conditions where the minutest forces can be detected, their instruments attuned to the whispers of the quantum realm. The implications of the Casimir effect extend far beyond the confines of a laboratory. They challenge our understanding of quantum theory itself. This phenomenon serves as a tangible example of vacuum energy, shedding light on the interplay between the void and the forces that shape our universe. As Richard Feynman once remarked, "The imagination of nature is far greater than the imagination of man." The Casimir effect illustrates how the vacuum is not just an absence, but a participant in the fundamental processes of the cosmos. This leads us to consider the relationship between the Casimir effect and cosmology. The vacuum energy observed in the Casimir effect raises intriguing questions about the energy density of space itself. Could this energy be linked to the mysterious dark energy that drives the acceleration of the universe? The connection between local phenomena, like the Casimir effect, and the vast cosmic tapestry of existence invites us to ponder profound truths. As we delve deeper into these concepts, we begin to realize that our understanding of vacuum energy is still evolving. It challenges us to rethink the very nature of space and its role in the universe. The echoes of Casimir's findings reverberate through the realms of theoretical physics and cosmology, inviting new explorations and insights. Imagine standing on the precipice of knowledge, peering into the depths of the quantum void. The Casimir effect serves as a reminder that even in what we perceive as emptiness, there lies a vibrant, pulsating reality. This realization not only deepens our scientific understanding, but also enriches our appreciation for the wonders of the universe, encouraging a sense of awe and curiosity that can soothe the restless mind. As we continue to explore the implications of the Casimir effect, we find ourselves on a journey through the unseen. It is a journey that reveals the interconnectedness of all things, guiding us toward a greater understanding of the cosmos and our place within it. Each step forward leads us to new revelations, expanding our horizon and illuminating the mysteries that lie just beyond our grasp. Let us embrace this voyage into the unknown, where the boundaries of science and imagination intertwine, revealing the beauty of the universe in all its complexity. The Casimir effect stands not just as a scientific curiosity, but as a portal to a deeper comprehension of reality, inviting us to explore the hidden energies that shape our existence. As we venture further into the heart of the Casimir effect, we encounter the concept of quantum foam, a term that evokes the very essence of space-time at its most fundamental level. Picture, if you will, a bubbling cauldron of energy. where the fabric of the universe is not solid but rather a frothy, dynamic sea, constantly shifting and evolving. This imagery captures the nature of space-time at microscopic scales, where virtual particles flicker in and out of existence, giving rise to the rich tapestry of reality we experience. The notion of quantum foam was popularized by physicist John Archibald Wheeler, who famously remarked, "No phenomenon is a phenomenon until it is an observed phenomenon." This statement emphasizes the profound role of the observer in quantum mechanics, a dance between reality and perception that colors our understanding of the universe. Imagine the implications of this perspective. The very act of observation shapes the world around us, blurring the lines between existence and non-existence. In this fluctuating landscape of space-time, the Casimir effect emerges as a tangible manifestation of these quantum fluctuations. It is a phenomenon that occurs when two uncharged conductive plates are placed a mere fraction of a millimeter apart in a vacuum. The plates, though seemingly inert, interact with the sea of virtual particles that permeates the space between them. As these particles pop into and out of existence, they create a pressure that pushes the plates together, leading to a measurable force. This counterintuitive result illustrates the extraordinary power of vacuum energy, revealing that emptiness is anything but empty. Experimental setups designed to measure the Casimir effect have undergone significant evolution since its discovery. In the early days, researchers relied on rudimentary apparatus to observe the force exerted by the vacuum. However, as technology advanced, so too did the sophistication of these experiments. Today, scientists utilize highly sensitive equipment, such as atomic force microscopes, to detect the subtle forces at play. These instruments allow them to observe the Casimir effect with remarkable precision, deepening our understanding of quantum mechanics and challenging our preconceived notions of the vacuum. Consider the work of Steve K. Lamoureux, who conducted groundbreaking experiments in the late 1990s. He meticulously crafted a setup to measure the Casimir force with unprecedented accuracy. Lamoureux's experiments not only confirmed earlier theoretical predictions, but also opened new avenues for exploring the implications of vacuum energy. His findings serve as a testament to human ingenuity, illustrating how curiosity and perseverance can unlock the secrets of the universe. As we reflect on the implications of the Casimir effect for quantum theory, we begin to see its far-reaching consequences. The interplay of vacuum energy and the fundamental forces of nature invites questions that beckon exploration. How does this force influence the behavior of particles? What role does it play in the larger framework of quantum field theory? The answers to these questions may reshape our understanding of reality itself. The Casimir effect also has profound implications for cosmology, the study of the universe's origins and its evolution over time. The vacuum energy associated with the Casimir effect is intrinsically linked to the concept of dark energy, a mysterious force thought to drive the accelerated expansion of the universe. Imagine the universe as a vast balloon, stretching ever larger with each passing moment. Dark energy is the unseen hand, guiding this expansion and challenging our understanding of gravity. Renowned physicist Einstein once said, "The most beautiful thing we can experience is the mysterious." This sentiment rings true as we grapple with the enigma of dark energy and its connection to vacuum fluctuations. The universe, in all its grandeur, reveals a complexity that transcends our current understanding. It invites us to ponder the nature of existence, reminding us that the answers we seek may lie just beyond the horizon of our knowledge. The implications of the Casimir effect extend not only to theoretical physics, but also to the philosophical discourse surrounding the nature of reality. What does it mean for something to possess energy when it appears to be empty? This paradox invites contemplation, urging us to reconsider our definitions of existence and non-existence. The interplay of vacuum energy and the observable universe challenges our perceptions, suggesting that the universe is far more intricate than we can fathom. As we ponder these profound questions, we are reminded of the words of physicist Richard Feynman: "The imagination of nature is far, far greater than the imagination of man." The Casimir effect exemplifies this truth, showcasing the remarkable phenomena that arise from the quantum realm. It beckons us to embrace the unknown, to venture into the depths of our curiosity with open hearts and minds. Consider the implications of harnessing vacuum energy. The potential applications are as vast as the universe itself. Could this energy be tapped for practical uses, offering solutions to some of humanity's most pressing challenges? The quest to utilize such elusive forces pushes the boundaries of innovation and creativity, inspiring future generations to explore the frontiers of science. As we draw closer to the mysteries of the universe, we find ourselves standing on the shoulders of giants, pioneers who dared to dream and explore the unknown. Each discovery leads us deeper into the intricate web of reality, inviting new questions and illuminating the dark corners of our understanding. The Casimir effect serves as a beacon, guiding us through the uncharted territories of quantum mechanics and cosmology. Imagine the day when we fully grasp the implications of vacuum energy. What new technologies might emerge? How will our understanding of the universe transform? As we continue to explore the Casimir effect and its relationship to vacuum energy, we are reminded that with each revelation comes a renewed sense of wonder and curiosity. Let us take a moment to breathe in this beauty, to appreciate the intricate dance of particles and forces that shape our existence. The universe is a symphony of energy and matter, a harmonious interplay that resonates through the fabric of space-time. As we delve into the depths of quantum mechanics, we find that the boundaries of science and imagination blur, revealing a reality that is at once beautiful and complex. As we continue this exploration, let us remain open to the mysteries that await us. The Casimir effect, with its profound implications, invites us to question, to wonder, and to seek deeper understanding. It is a journey that unfolds before us, a path illuminated by the light of discovery, a light that shines ever brighter as we embrace the vastness of the unknown. What new horizons shall we uncover together? The adventure is just beginning. As we traverse this uncharted territory, we come face to face with the essence of the Casimir effect. Discovered by Dutch physicist Hendrik Casimir in the early 20th century, this phenomenon reveals the tangible consequences of vacuum energy. When two uncharged parallel plates are placed in a vacuum, they experience an attractive force, drawn from the fluctuations of the vacuum itself. This seemingly simple setup symbolizes a profound truth. Even in the emptiness of space, something remarkable is at play. Imagine, if you will, the space between these plates. It's not just a void, but a dynamic arena where virtual particles flicker in and out of existence. These fleeting entities create a subtle pressure that influences the plates, a testament to the reality that nothing is truly empty. As Casimir himself eloquently stated, a vacuum is not an empty space, but a reservoir of energy. Experimental setups designed to demonstrate the Casimir effect have revealed astonishing results, encouraging physicists to rethink the nature of reality. Over the years, various teams have crafted intricate devices to measure this force, with some employing advanced techniques such as atomic force microscopy. The meticulous precision required highlights the dedication of researchers who venture into the microscopic world, revealing the elegant and often hidden interactions that govern our universe. What does it mean for quantum theory as a whole? The implications are vast, suggesting that vacuum energy may play a pivotal role in the fundamental workings of nature. This connection to quantum field theory invites us to reconsider our understanding of the cosmos and its seemingly empty spaces. The Casimir effect serves as a bridge, linking the microscopic realm of quantum mechanics to the grand scale of cosmology. As we contemplate these revelations, we might ask ourselves how the fabric of the universe is woven together. Could the interplay of vacuum energy and the Casimir effect provide insights into dark energy, that enigmatic force driving the universe's expansion. The possibility tantalizes our imaginations, suggesting that the mysteries embedded in the Casimir effect may hold keys to unlocking the secrets of the universe itself. In this dance of energy and existence, we are called to embrace the beauty of uncertainty. The Casimir effect invites us to ponder the profound questions that lie at the intersection of science and philosophy. As we explore this realm, we discover that every layer of reality is imbued with significance, each fluctuation echoing the whispers of creation. Shall we continue to journey deeper into this exquisite tapestry? The universe awaits our inquiry, inviting us to explore further the wonders of vacuum energy and its implications for our understanding of existence. As we stand on the threshold of understanding the Casimir effect, it becomes clear that the vacuum is not merely a backdrop, but a vital player in the grand narrative of the cosmos. The implications we've unearthed challenge our perceptions of reality, beckoning us to delve deeper into the intricate ways in which vacuum energy shapes the universe. With this foundation laid, we are poised to explore the fascinating influence of the quantum vacuum on particle interactions, where the creation and annihilation of particles unfold in a dance dictated by the very energy of emptiness. As we transition into the next chapter, let us uncover how these vacuum dynamics contribute to the standard model of particle physics, revealing yet another layer in the exquisite tapestry of existence. Chapter 5. The role of quantum vacuum in particle physics. The concept of the quantum vacuum is not merely an absence of matter, but a rich, dynamic arena, where the fabric of reality is woven from energy and possibility. One of the most striking demonstrations of this intriguing nature is the Casimir effect, a phenomenon that brings the idea of vacuum energy into vivid relief. Imagine two unyielding plates placed mere micrometers apart in a vacuum. The space between them is devoid of matter, yet it is not empty. Instead, it teems with virtual particles constantly flickering in and out of existence. As these particles exert pressure, they create a measurable force that pushes the plates together. This compelling evidence showcases the reality of vacuum energy, one of the many marvels hidden within the quantum realm. How does the quantum vacuum influence particle interactions? In the world of particle physics, interactions between particles are rarely straightforward. They are often mediated by virtual particles that emerge from the vacuum itself. Picture a bustling marketplace where traders exchange goods, each transaction affecting the market's dynamics. In the same way, particles exchange forces through these ephemeral virtual entities. This interaction is fundamental to the way particles communicate and influence one another, making the quantum vacuum an essential player in the drama of particle physics. The vacuum is not merely a backdrop for these interactions. It plays a crucial role in the creation and annihilation of particles. When energy is injected into the vacuum, it can give rise to particle-antiparticle pairs that appear momentarily before annihilating each other, returning their energy to the vacuum. This cycle of birth and demise is a testament to the fluidity of existence at the quantum level. As physicist Richard Feynman once said, "The universe is not simply a collection of particles, it is a collection of interactions." The vacuum serves as the stage upon which these interactions unfold, reinforcing the notion that nothingness is a vibrant source of activity. The implications for the standard model of particle physics are profound. The standard model, the framework that describes the fundamental particles and forces of the universe, relies on the concept of the vacuum to explain how particles acquire mass. Through a mechanism known as the Higgs effect, particles interact with the Higgs field, which permeates the vacuum. This interaction transforms their energy into mass, allowing them to manifest as the particles we observe. The vacuum, therefore, is not merely a passive entity. It is an active participant in the formation of the physical universe. As we delve deeper into the interplay of vacuum energy and mass generation, we begin to see the intricate dance of forces at work. Imagine a vast ocean with waves representing the energy fluctuations of the vacuum. These waves can condense into particles, giving rise to the matter that constitutes our reality. The Higgs field, often visualized as a thick syrup, slows down certain particles while allowing others to glide freely. This process creates a spectrum of masses among particles. Thus, the quantum vacuum is not just a void, it is a wellspring of mass and energy, intricately woven into the very fabric of existence. One cannot help but wonder about the implications of these discoveries. What does it mean for our understanding of the universe? The quantum vacuum challenges our intuition, revealing a world where emptiness is alive with potential. As we explore the depths of particle physics, we find that the vacuum is not a mere absence, but a vital force shaping the cosmos. It invites us to embrace a more nuanced view of reality, one where the unseen plays a crucial role in the grand tapestry of existence. Within this framework, the boundaries of science and philosophy blur. The inescapable truth is that the quantum vacuum holds secrets that may redefine our comprehension of nature. It beckons us to ponder the very essence of reality, urging us to look beyond the visible and appreciate the intricate mechanisms that govern our universe. As we continue to unravel these mysteries, we find ourselves at the precipice of a deeper understanding of not just the cosmos, but our place within it. This journey into the quantum vacuum is not merely an academic pursuit, it is an exploration of existence itself. The more we learn about the vacuum, the more we uncover about the fundamental nature of reality. It is a reminder that even in our most profound inquiries, we must remain open to the unexpected, to the marvels that lie hidden in the void. As we stand on the brink of discovery, we invite the wonder of the unknown, for it is here, in the shadows of the vacuum, that the most extraordinary revelations await. The Casimir effect serves as a striking illustration of the quantum vacuum's tangible influence. Imagine two unyielding metal plates placed in the vastness of empty space, yet separated by mere micrometers. In this seemingly barren region, the vacuum teems with virtual particles fluctuating in and out of existence. As these particles emerge, they create a pressure that pushes the plates together. This phenomenon, first theorized by Dutch physicist Hendrik Casimir in the 1940s, provides a vivid demonstration of vacuum energy in action. Casimir's insight transformed our understanding of what it means for space to be empty. What does this mean for the nature of vacuum energy? It suggests that the vacuum itself is a battleground for forces, where the unseen interactions of virtual particles exert measurable effects on the physical world. This revelation invites us to reconsider our definitions of energy and matter, as the vacuum emerges as a dynamic player in the theater of particle physics. As the eminent physicist Richard Feynman remarked, "There is plenty of room at the bottom," hinting at the vast potential that lies hidden in the quantum realm. Yet, how does the quantum vacuum influence particle interactions beyond the confines of the Casimir effect? Consider the intricate web of forces between particles. Quantum field theory posits that particles are not isolated entities, but rather excitations in underlying fields permeating the cosmos. These fields, like the fabric of reality itself, are shaped by the vacuum. When particles interact, they exchange virtual particles, which are born from the vacuum, momentarily borrowing energy from this ephemeral realm. This interplay is pivotal in processes such as electromagnetic interactions and the strong force that binds atomic nuclei together. Imagine a world where each fleeting moment, each interaction between particles, is a dance choreographed by the quantum vacuum itself. This dance is not random. It follows the principles of quantum mechanics, weaving a complex narrative of creation and destruction. Every time a particle encounters another, the vacuum plays a role, shaping the outcomes of these encounters in ways that often elude our understanding. The concept of particle creation and annihilation is a cornerstone of quantum field theory. In this dynamic tapestry, particles can emerge from the vacuum, gaining mass and energy, only to disappear back into the void. This ephemeral existence raises profound questions. What does it mean for a particle to come into being? What is the significance of its subsequent annihilation? The processes of particle creation and annihilation remind us of the impermanence inherent in nature. As the physicist Wolfgang Pauli once expressed, The absence of evidence is not evidence of absence. In the quantum vacuum, absence and presence coexist, shaping the universe in profound ways. In recent years, researchers have delved deeper into how vacuum energy contributes to the standard model of particle physics. This model, which elegantly describes the fundamental particles and forces of the universe, has been bolstered by the understanding that the vacuum is not an empty backdrop, but an active participant in the grand narrative of particle interactions. Consider the Higgs field, a vital element of the standard model that bestows mass upon elementary particles. The Higgs boson, discovered in 2012, serves as a tangible manifestation of this field. As particles traverse this field, they interact with it, acquiring mass in the process. In a sense, the vacuum acts as a stage upon which the drama of matter unfolds, with the Higgs field providing the necessary conditions for mass to emerge. This revelation has profound implications for our understanding of the universe, as it unveils the intricate connections between mass, energy, and the quantum vacuum. As we ponder the implications of vacuum energy for mass generation, we are led to consider the remarkable interplay between energy and matter. Einstein's famous equation, E=mc², encapsulates this relationship, revealing that energy and mass are two sides of the same coin. In the context of the quantum vacuum, this relationship becomes even more intricate. The energy fluctuations within the vacuum can give rise to mass, suggesting that the very fabric of our reality is woven from the fabric of energy itself. Imagine a universe where mass is not a static property, but a dynamic consequence of quantum interactions. This perspective challenges our traditional views and invites us to embrace a more fluid understanding of existence. The vacuum, with its vibrant energy fluctuations, becomes a crucible of creation, where the very essence of matter is forged. As we explore these ideas, we must also confront the implications of vacuum energy for the cosmos at large. The universe, with its vast expanse, is not merely a stage for celestial bodies, but an arena where quantum processes unfold on scales beyond our comprehension. The interplay between vacuum energy and cosmic evolution raises questions about the very nature of our universe. Could the vacuum hold the key to understanding dark energy, the mysterious force driving the accelerated expansion of the cosmos? Some theorists posit that vacuum energy may play a crucial role in this cosmic phenomenon, suggesting that the energy of the vacuum itself could be a driving force behind the universe's expansion. This tantalizing possibility invites us to reconsider our understanding of cosmic structure, evolution, and the fabric of space-time itself. As we delve deeper into the role of the quantum vacuum, we find ourselves grappling with profound philosophical questions about existence and reality. The vacuum challenges our intuitions, blurring the lines between the known and the unknown. It urges us to embrace uncertainty, for within the depths of the vacuum lie mysteries waiting to be uncovered. In this journey of discovery, we find ourselves echoing the sentiments of the physicist Niels Bohr, who famously stated, "We must be careful not to confuse data with the actual world." The quantum vacuum invites us to remain humble, to recognize that our understanding is but a reflection of our current knowledge, constantly evolving as we unveil the layers of reality. As we continue to explore the quantum vacuum's role in particle physics, we are reminded that our inquiries are not just scientific in nature, they are deeply philosophical. The quest to understand the vacuum is a quest to understand ourselves, our place in the universe, and the fundamental forces that shape our existence. With each revelation about the quantum vacuum, we inch closer to a more profound understanding of the interplay between energy, matter, and the cosmos. As we stand at the forefront of this exploration, we invite curiosity and wonder into our hearts, for it is through questioning and seeking that we illuminate the shadows of the unknown. The quantum vacuum, a realm of infinite possibilities, beckons us to journey further into the depths of reality, where the mysteries of existence await our discovery. As we contemplate the profound implications of the quantum vacuum on our understanding of existence, we find ourselves standing at the threshold of a broader cosmic narrative. The mysteries we have unearthed thus far hint at a deeper connection between the vacuum's dynamic energy and the very fabric of the universe itself. This next chapter invites us to explore how these quantum fluctuations not only influence particle physics, but also serve as a pivotal force in cosmic inflation and the enigmatic nature of dark energy. As we delve into the intricate relationship between the quantum vacuum and the evolution of the universe, we will uncover how these concepts intertwine to shape the cosmos we inhabit. With each revelation, we move closer to grasping the full scope of reality, where the dance of energy and matter unfolds on a grand scale. Chapter 6: Quantum Vacuum in Cosmology and the Universe. In the vast and mysterious expanse of the cosmos, the concept of vacuum energy emerges as a profound force, subtly shaping the universe's evolution. Imagine a space devoid of matter, yet brimming with energy, a quantum vacuum that plays an essential role in the ongoing cosmic expansion. This invisible energy, residing in the fabric of empty space, is not merely a theoretical abstraction. It actively influences the universe's destiny. Quantum vacuum energy is intricately linked to the phenomenon of cosmic inflation, a rapid expansion that occurred shortly after the Big Bang. During this brief period, the universe expanded exponentially, driven by a smooth and efficient force that we now attribute to vacuum energy. The remarkable physicist Alan Guth, who pioneered the inflationary model, suggested that this energy density could have provided the impetus for the universe's swift growth. Have you ever wondered what it would be like to witness such an explosive beginning? The cosmos, stretching and expanding, carried the seeds of all structures that would later form the galaxies, stars, and planets we see today. As we delve deeper into the nature of vacuum energy, we encounter its pivotal role as a candidate for dark energy. This elusive force constitutes a significant portion of the universe, yet it remains largely misunderstood. Dark energy acts as a driving force behind the accelerated expansion of the universe, pushing galaxies apart at an ever-increasing rate. The relationship between dark energy and vacuum energy is a subject of intense research and speculation. Theoretical physicist Lawrence Krauss eloquently stated, "The amazing thing is that every particle in the universe comes from the vacuum." This perspective invites us to consider the vacuum not merely as emptiness, but as a vibrant source of energy, intricately woven into the fabric of our universe. The implications of quantum vacuum energy extend beyond mere expansion. They profoundly impact the evolution of the universe itself. From the formation of cosmic structures like galaxies to the dynamics of cosmic microwave background radiation, vacuum energy serves as a fundamental component in understanding the universe's history. Picture the delicate balance of forces that allowed matter to coalesce into stars and galaxies, influenced by the unseen hand of vacuum energy. This energy plays a role in shaping the universe's structure over billions of years, guiding the dance of creation and destruction. One of the most captivating theories connecting vacuum fluctuations to cosmic structures is the idea that these fluctuations, born from the quantum vacuum, could seed the formation of galaxies and clusters. Imagine the universe as a quiet sea, with tiny ripples forming and expanding, leading to the grandeur of cosmic structures. Each fluctuation carries with it potential, a whisper of energy that can translate into the formation of vast galaxies or the birth of new stars. The fluctuations exist in a delicate interplay with gravity, influencing the distribution of matter and energy throughout the cosmos. Prominent cosmologist and astrophysicist Stephen Hawking once mused, "The universe is not just a place, it is a collection of ideas." His insight encapsulates the essence of how quantum vacuum energy and its fluctuations inform our understanding of the universe. They are not merely phenomena to be measured, but concepts that shape our perception of reality itself. As we ponder the intricate web of cosmic structures, we begin to see the universe as a living entity, continuously evolving and shaping itself through the very energy of its own vacuum. The relationship between quantum vacuum energy and cosmic inflation opens new avenues of thought. Can we envision a universe that is not static but rather a dynamic interplay of forces? Each moment, the energy of the vacuum contributes to the cosmos, creating conditions ripe for change and evolution. This ongoing cosmic process invites us to reflect on the nature of existence itself. What does it mean to be a part of a universe that is perpetually expanding, driven by an unseen energy? As we explore the contours of vacuum energy, we find ourselves at the intersection of cosmology and the fundamental laws of physics. The universe, with all its vastness, adheres to principles dictated by quantum mechanics. The vacuum, often perceived as a barren void, is instead a fertile ground for the potentiality of existence. The interplay of vacuum fluctuations and cosmic structures highlights the significance of what lies beneath the surface of our understanding. Each discovery about vacuum energy, each insight into its role in cosmic expansion, brings us closer to unraveling the mysteries of the universe. The cosmos invites us to delve deeper, to ponder the connections between the microscopic and the macroscopic, and to embrace the notion that every atom, every galaxy, reflects the energy of the void from which it sprang. This realization can be both humbling and awe-inspiring as we recognize our place within this grand tapestry of existence. As we conclude our exploration of the quantum vacuum's role in cosmology, we are left with an array of questions and reflections. What further secrets does the vacuum hold? How might our understanding of vacuum energy evolve as we continue to explore the cosmos? The universe remains a realm of wonder, a space where science and imagination intertwine, encouraging us to think beyond the confines of our current knowledge. In the stillness of the night sky, when the stars twinkle like distant memories, we are reminded of the profound interconnectedness of all things. The energy of the vacuum flows through everything, binding us to the cosmos in ways we are only beginning to comprehend. So, as we gaze upward, let us embrace the mysteries and marvel at the beauty of a universe shaped by the very essence of emptiness, filled with potential and wonder. The concept of vacuum energy is not merely an abstract idea confined to the realm of theoretical physics. It plays a vital role in our understanding of cosmic expansion. Imagine a balloon, gently inflated as you blow air into it. Each breath fills the balloon, causing it to expand. In an analogous way, vacuum energy contributes to the expansion of the universe itself, pushing galaxies apart in a grand display of cosmic dynamics. This expansion has been confirmed through observations of distant supernovae, which reveal that the universe is not just expanding, but accelerating in its growth. As we ponder the implications of vacuum energy, we encounter the theory of cosmic inflation. This theory, proposed in the 1980s by physicist Alan Guth, suggests that the universe underwent an exponential expansion in the moments following the Big Bang. Picture for a moment a tiny speck of dust suddenly swelling into a vast expanse. Guth's insight was that the energy density of the vacuum could drive this rapid expansion, smoothing out the irregularities in the infant universe and setting the stage for the formation of galaxies and stars. Isn't it fascinating to consider that the very fabric of space and time was influenced by the ephemeral nature of vacuum energy? As the universe cooled, the energy of the vacuum began to manifest in the form of particles and radiation, leading to the rich structural complexity we observe today. The quantum vacuum, once a mere backdrop, became an active participant in the cosmic drama. This leads us to the notion of dark energy, which has emerged as a compelling candidate for the force driving the accelerated expansion of the universe. Dark energy, constituting about 70% of the total energy density of the universe, remains one of the most profound enigmas in modern cosmology. As cosmologist Michael Turner eloquently stated, "The discovery of dark energy is a profound surprise that will change our understanding of the universe." Imagine, if you will, a universe where this mysterious energy is woven into the very fabric of existence. It is as if the cosmos has a hidden hand, gently pushing galaxies apart, orchestrating the grand ballet of cosmic evolution. This unseen force, tied intricately to vacuum energy, raises intriguing questions about the fate of our universe. Will it continue to expand forever, or will it eventually slow down and collapse upon itself? The impact of quantum vacuum extends beyond mere cosmic expansion. It influences the very evolution of the universe. As fluctuations in the vacuum give rise to particles and fields, they shape the large-scale structure of the cosmos. These fluctuations can be likened to the ripples on the surface of a pond, where each disturbance creates a pattern that radiates outward. Such patterns, born from vacuum energy, manifest as galaxies, clusters, and superclusters, forming a vast web of interconnectedness that defines the universe's architecture. Theories connecting vacuum fluctuations to cosmic structures have blossomed, offering a glimpse into the underlying mechanisms of our universe. Notably, the work of physicist André Linde has delved into how these fluctuations could seed the formation of galaxies. His ideas suggest that small quantum variations during the inflationary period could lead to density fluctuations, which ultimately give rise to the grand structures we observe today. Can one imagine the intricate dance of particles and forces shaping the universe? Each fluctuation, each ripple in the quantum vacuum, potentially leading to the birth of stars and galaxies, illustrates the profound interconnectedness of all things. As we journey through the cosmos, it becomes apparent that these seemingly random quantum events are anything but trivial. They are, in fact, the building blocks of existence. As we contemplate the vastness of the universe, a deeper appreciation for the quantum vacuum emerges. It is a realm filled with energy, potential, and the origins of structure. The vacuum, long dismissed as empty, reveals itself as a dynamic and vibrant field, teeming with possibilities. Each galaxy swirling in the night sky is a testament to the profound influence of vacuum energy, embodying the very essence of creation. The interplay between vacuum energy and cosmic structures invites us to ponder the nature of reality itself. What does it mean for something to arise from nothing? The ancient philosopher Lao Tzu once remarked, "Nature does not hurry, yet everything is accomplished." In the cosmos, this wisdom resonates as we witness the unfolding of galaxies over vast stretches of time. The universe, in its intricate design, seems to embrace a rhythm, allowing the quantum vacuum to play its role in the symphony of existence. As we explore these concepts, we are reminded of the importance of curiosity and inquiry. Each question we ask about the universe opens a door, inviting us to explore new realms of understanding. With every discovery, we find ourselves standing on the shoulders of giants, such as Richard Feynman, who once said, "The pleasure of finding things out is one of the most incredible sources of excitement in my life." This excitement fuels our quest to understand the cosmos and our place within it. In the vast expanse of the universe, the quantum vacuum serves as both a canvas and a crucible for creation. It challenges our perceptions and invites us to witness the beauty of existence, where the invisible becomes visible, and the potential within emptiness gives rise to the magnificent. As we delve deeper into the mysteries of vacuum energy and its role in cosmic expansion, we find ourselves intertwined with the very essence of the universe, an eternal dance of creation, evolution, and discovery. What lies ahead in our exploration of the quantum vacuum? The answers remain elusive, yet the journey promises to be as enriching as the knowledge we seek. With each new insight, we are reminded of our connection to the cosmos, a reminder that we are not separate from the universe but an integral part of its grand narrative. As we continue this journey, may we remain open to the wonders that await us, drawing inspiration from the beauty of a universe that thrives on possibility. As we reflect on the profound implications of the quantum vacuum, we recognize that its influence extends far beyond the cosmic scale, reaching into the very technologies that shape our daily lives. The mysteries of vacuum energy not only deepen our understanding of the universe, but also pave the way for innovative applications that harness its potential. As we turn our gaze toward the practical realms of quantum vacuum concepts, we will explore how these foundational ideas are revolutionizing fields such as quantum computing, and precision measurement. The journey into these applications promises to illuminate the tangible benefits that arise from our understanding of the invisible forces at play. Join us as we delve into the remarkable ways in which the quantum vacuum is catalyzing advancements that may redefine our future. Chapter 7. Practical Applications of Quantum Vacuum Concepts. The quantum vacuum, once dismissed as mere emptiness, is now understood to be a rich tapestry of activity and potential. Its implications for particle physics are profound. At the heart of these implications lies the idea that the vacuum is not just a void, but a dynamic realm where particles and antiparticles can emerge spontaneously, only to vanish again in an ephemeral dance. This reality challenges our understanding of matter and energy, revealing that even the most fundamental particles are influenced by the vacuum. Imagine the vacuum as a stage, with particles as the actors, and vacuum fluctuations as the script. It is on this stage that particles can interact in ways that defy classical intuition. The work of physicists, such as Richard Feynman and Steven Weinberg, has illuminated how these vacuum fluctuations can lead to observable phenomena. Feynman famously remarked, "The only thing that matters is that our theories agree with experiment." The implications of the quantum vacuum extend to the heart of particle physics, where it affects interactions and gives rise to the properties of observed particles. As scientists delve deeper into the mysteries of quantum mechanics, they are uncovering practical applications of these concepts, particularly in the realm of technology. Quantum computing, for instance, leverages the principles of superposition and entanglement, both of which are influenced by the quantum vacuum. In a quantum computer, qubits exist in a state of superposition, allowing them to perform calculations at speeds unimaginable with classical computers. This capability is rooted in the behavior of particles at the quantum level, where the vacuum plays a crucial role. Imagine the vast potential of a quantum computer that harnesses the very fluctuations of the vacuum itself. This technology could revolutionize fields ranging from cryptography to materials science. As we explore this frontier, we find ourselves asking, how will our understanding of the quantum vacuum shape the future of computation? The answer lies in the intricate dance of particles and the rules that govern their interactions, all emerging from the seemingly empty space around us. Beyond computing, the quantum vacuum has significant applications in precision measurement and sensors. The delicate interplay of vacuum fluctuations can enhance the sensitivity of measurements, allowing scientists to detect forces and changes that would otherwise go unnoticed. For instance, gravitational wave detectors, like LIGO, utilize these principles to observe the minute ripples in space-time caused by distant cosmic events. Consider the implications of being able to measure the most subtle forces in the universe. It is a testament to our ingenuity and our understanding of quantum phenomena. Innovations in sensor technology, driven by insights from quantum vacuum physics, promise to pave the way for advancements in numerous fields, from environmental monitoring to medical diagnostics. Nanotechnology, the manipulation of matter on an atomic and molecular scale, greatly benefits from our understanding of vacuum fluctuations. The interactions of particles at this scale are profoundly influenced by the quantum vacuum. Researchers are exploring how these fluctuations can be harnessed to create materials with unique properties, leading to advancements in electronics, medicine, and energy. Imagine a future where materials can be engineered at the nanoscale to respond dynamically to their environment. This could lead to smart materials that change their properties based on external stimuli, revolutionizing industries from construction to healthcare. As physicist Niels Bohr once said, "We are all just a bunch of atoms, and we are all connected." The possibilities for innovation are boundless as we tap into the intricate relationship between the quantum vacuum and nanotechnology. One of the most exciting prospects of quantum vacuum research is its potential application in energy harvesting and propulsion. The fluctuations of the vacuum may offer new avenues for capturing energy from the environment, transforming our approach to energy generation. Concepts such as zero-point energy, the energy that resides in the vacuum even at absolute zero, are being explored for their practical applications. Imagine a world where we can harness the energy of the vacuum itself to power our homes, vehicles, and devices. This vision may sound like science fiction, but the seeds of this possibility are being planted in laboratories worldwide. Scientists are investigating how vacuum fluctuations might be utilized to create propulsion systems that operate on principles entirely different from traditional fuel-based engines. This could lead to breakthroughs in space travel, allowing humanity to explore the cosmos in ways previously thought impossible. As we explore these practical applications, we are reminded of the words of physicist Albert Einstein. The most beautiful thing we can experience is the mysterious. The quantum vacuum, with all its complexities and potential, invites us to embrace the unknown and push the boundaries of our understanding. In this journey through the implications and applications of quantum vacuum concepts, we find ourselves at the intersection of science and imagination. Each discovery leads to new questions and challenges our perceptions of reality. With every advancement, we inch closer to unlocking the secrets of the universe, realizing that what we once thought of as empty space is a wellspring of opportunity, waiting to be explored. As we delve into the practical applications of these concepts, the horizon of possibility expands before us. What will our future hold as we continue to unravel the mysteries of the quantum vacuum? Each step forward marks a new beginning, a chance to redefine our relationship with the universe and embrace the marvels that await us. As we ponder the implications of the quantum vacuum, we begin to understand how its phenomena influence particle physics in profound ways. The vacuum is not merely an empty stage. It acts as a dynamic arena where particles emerge, interact, and vanish in a ceaseless ballet of creation and annihilation. This dance offers insights into the fundamental forces of nature. For instance, the way in which vacuum fluctuations can affect particle masses and interactions has been a key element in refining the standard model of particle physics. Imagine a world where scientists can manipulate these vacuum fluctuations. They might be able to enhance particle collision experiments, leading to discoveries that could illuminate the very fabric of reality. As physicist Richard Feynman once said, "The imagination of nature is far, far greater than the imagination of man." With this in mind, one can envision how tapping into the essence of the quantum vacuum might lead to entirely new branches of physics, unlocking secrets that have eluded us for centuries. Quantum computing represents one of the most promising practical applications of quantum vacuum concepts. This frontier technology harnesses the principles of superposition and entanglement, which are deeply rooted in quantum mechanics, including the behaviors of particles in the vacuum. When we think of quantum computers, we often picture them as advanced machines capable of solving problems in mere moments that would take classical computers years. These devices operate on qubits, which can exist in multiple states simultaneously, echoing the nature of virtual particles that flit in and out of existence. The potential of quantum computing may seem boundless. Consider how it could transform fields such as cryptography and drug discovery. In drug development, for example, quantum computers could simulate molecular interactions with unprecedented accuracy, paving the way for breakthroughs in medicine. The ability to explore complex biochemical environments may lead to the discovery of new therapies for diseases that have long resisted treatment. Furthermore, the application of quantum vacuum concepts extends into the realm of precision measurement and sensors. At the very heart of these technologies lies the fundamental nature of the vacuum itself. Advanced sensors that exploit quantum fluctuations can achieve levels of sensitivity previously thought unattainable. Imagine a gravitational wave detector so finely tuned that it could pick up the slightest ripples in space-time, allowing us to observe cosmic events billions of light years away. This could deepen our understanding of the universe's origins and evolution, revealing the secrets hidden within the vast expanse of space. The significance of vacuum fluctuations also permeates the field of nanotechnology, where the manipulation of materials at the atomic and molecular levels has become a cornerstone of innovation. Researchers are delving into how exploiting vacuum properties can lead to the development of new materials with tailored characteristics. For instance, these materials may exhibit enhanced electrical properties or unique optical behaviors, opening doors to novel applications in electronics and photonics. Imagine nanobots powered by quantum vacuum phenomena, capable of performing intricate tasks at the cellular level, revolutionizing healthcare and environmental management. The vision of self-repairing materials or sensors that can detect environmental pollutants at an atomic scale becomes more tangible as we further explore the capabilities of the quantum vacuum. Energy harvesting stands as another exciting avenue where quantum vacuum concepts may hold the key to sustainable solutions. Researchers are investigating mechanisms that could allow us to capture energy from vacuum fluctuations, potentially fueling our quest for renewable energy. Picture devices that convert these fluctuations into usable power, creating a continuous energy supply independent of traditional sources. This could reshape our energy landscape, reducing reliance on fossil fuels and minimizing our environmental impact. Propulsion technologies may soon benefit from insights gained through the study of the quantum vacuum. Concepts of propulsion that defy conventional understanding are emerging, with scientists exploring ways to leverage vacuum fluctuations to create thrust. Imagine spacecraft that harness the energy of the vacuum to glide effortlessly through the cosmos, minimizing the need for traditional fuel sources. The prospect of interstellar travel, once confined to the realm of science fiction, might become a reality as our understanding of the quantum vacuum deepens. As we stand on the brink of these scientific advancements, we find ourselves in a unique position. Each new discovery invites us to reconsider our relationship with the universe, urging us to ask questions that challenge our assumptions. How can we utilize the mysteries of the quantum vacuum to enhance our technological capabilities? What ethical considerations arise as we tread into this new territory? The stories of pioneers in these fields serve as a reminder of the importance of curiosity and perseverance. Innovators like John von Neumann and David Deutsch have laid the groundwork for quantum computing, inspiring a new generation to push the boundaries of knowledge. Their words echo through the halls of laboratories and universities. The greatest advances in science happen when what is believed is contradicted by what is observed. As we explore the vast potential of quantum vacuum concepts, we are reminded that progress is often born from the willingness to embrace uncertainty. The universe, with its myriad mysteries, beckons us forward. Each question we ask, each concept we explore, brings us closer to unraveling the wonders of existence itself. What lies ahead in this uncharted territory of quantum vacuum applications? The answers await in the whispers of the cosmos, ready to be discovered by those who dare to seek. The journey through the quantum realm is just beginning, and the possibilities stretch far beyond the horizons of our imagination. In this rich landscape of scientific inquiry, we find not only a quest for knowledge, but also a profound sense of connection to the universe and each other. It is a reminder that, in our pursuit of understanding, we are all part of a grand narrative that continues to unfold. As we stand on the cusp of a new era shaped by the practical applications of quantum vacuum concepts, we must also pause to reflect on the deeper implications of these advancements. The very nature of what we consider empty space challenges our understanding of reality, prompting us to reevaluate our existence within the cosmos. This burgeoning knowledge invites philosophical inquiry into the ontological status of the vacuum and its paradoxical role as a potential source of energy. As we delve into these philosophical implications, we begin to uncover the intricate dance between science and philosophy, revealing how our interpretations of the quantum realm can reshape our perception of reality itself. Join us in the next chapter, where we will explore these profound questions and the debates that arise from our evolving understanding of the universe. Chapter 8. Philosophical Implications of Quantum Vacuum. Imagine a vast, silent expanse, an ocean of emptiness that teems with potential, where the very fabric of existence begins to shimmer and pulse, revealing that what we perceive as nothingness is, in fact, a bubbling cauldron of quantum activities. This realm, known as the quantum vacuum, is not merely a void, but a stage for quantum fluctuations, where fleeting virtual particles emerge and vanish in a heartbeat. These fluctuations, like whispers of the universe, influence reality in profound ways, challenging our understanding of existence itself. What if I told you that the very nature of reality may hinge upon these imperceptible movements within the quantum vacuum? The concept of reality as shaped by these fluctuations invites us to reconsider our definitions of existence. As the physicist Richard Feynman once remarked, the more you learn about quantum mechanics, the more you realize that everything is connected. This connection transcends traditional notions, suggesting that even what seems like empty space is rich with possibilities, waiting to be explored. The ontological status of the vacuum has become a topic of vibrant discussion within modern philosophy. Philosophers and scientists alike ponder the implications of a universe where the vacuum is dynamic and alive with energy. Can we truly call it empty if it is the birthplace of virtual particles? If the vacuum is a source of energy, does that not challenge our conventional views on existence? Martin Heidegger, a prominent philosopher, suggested that being is the most universal concept. Yet what if the essence of being lies in that which we cannot see, in the subtle energies of the vacuum? Consider the paradox of empty space acting as a source of energy. At first glance, it seems counterintuitive. How can something that appears to be void give rise to energy? This paradox invites us to reflect on the nature of existence. The vacuum fluctuates with energy that, although imperceptible, influences the universe's grand tapestry. The idea that nothing can be a source of something challenges our intuitive understanding of physics and reality. It poses a question: if empty space can produce energy, what else might it hold, waiting to be discovered? The philosophical debates surrounding the interpretation of quantum mechanics further complicate our understanding of reality. Various interpretations, such as the Copenhagen interpretation and many worlds theory, grapple with the implications of quantum phenomena, including those originating from the vacuum. The Copenhagen interpretation implies a level of uncertainty that can be unsettling. It suggests that until we observe a particle, it exists in a state of probability, a concept that can be difficult to reconcile with our everyday experiences. Meanwhile, the many worlds interpretation offers a different perspective, proposing that every quantum event creates a branching of realities. This idea tantalizes our imaginations. Could there be infinite versions of ourselves living out different possibilities? In this intricate dance of philosophical inquiry and scientific exploration, the quantum vacuum serves as a profound reminder that reality may not be as straightforward as we believe. It invites us to question our perceptions and to delve deeper into the essence of existence. Just as the poet Rainer Maria Rilke wrote, "The only journey is the one within." The journey into understanding the quantum vacuum is one that leads us to explore the very foundations of our reality. As we ponder these concepts, we might find ourselves reflecting on the limits of human understanding. How much do we truly know about the universe we inhabit? The quantum vacuum, with its energetic fluctuations and elusive particles, suggests that our knowledge is but a flickering candle in an expansive darkness. This realization can be both humbling and exhilarating as we stand on the precipice of discovery, poised to illuminate the shadows of the unknown. The implications of these philosophical musings extend beyond mere speculation. They shape our approach to science and how we engage with the mysteries of the cosmos. The understanding that the vacuum is not empty but alive with energy reverberates through our theories and experiments. It urges us to look beyond the surface, and to embrace the complexities of existence. Imagine a world where the vacuum is not just a backdrop for cosmic events, but a dynamic participant in the unfolding story of the universe. In this view, existence itself becomes a rich interplay of energies and particles, a symphony composed of the visible and the invisible. The idea that empty space can nurture the birth of particles challenges us to see the world in a new light. It beckons us to explore the unseen, to listen to the whispers of the universe that echo through the vacuum. As we delve deeper into these philosophical implications, we encounter the concept of energy conservation. The quantum vacuum, with its constant fluctuations, poses intriguing questions about the nature of energy itself. If energy can arise from what we perceive as nothing, how then do we define the boundaries of conservation? This inquiry leads us to reconsider established laws of physics and to explore the interconnectedness of all things. The delicate balance between energy and nothingness also invites us to reflect on the nature of existence itself. What does it mean to exist in a universe where the vacuum can generate energy? Does it imply that existence is inherently intertwined with the fabric of the cosmos, where every particle and wave is inextricably linked to the quantum vacuum? This perspective encourages us to embrace a more holistic view of reality, one that recognizes the interplay of energies that define our existence. Philosophical debates surrounding quantum mechanics also touch upon the nature of observation and reality. In a universe where observation affects outcomes, what role does the observer play in shaping existence? Can we truly separate ourselves from the reality we observe? This question resonates deeply within the philosophical realm, suggesting that our consciousness may be a fundamental aspect of the universe itself. As physicist John Wheeler famously stated, we are not only observers of the universe, we are also participants. These reflections lead us to consider the future of our understanding of quantum mechanics and the vacuum itself. The implications of these ideas for science and philosophy are profound, hinting at a convergence of disciplines that may reshape our understanding of the universe. The quest to unravel the mysteries of the quantum vacuum is not merely a scientific endeavor. It is a philosophical exploration that challenges our very notions of reality and existence. As we continue our journey through the rich landscape of quantum mechanics, we are reminded that the pursuit of knowledge is an ever-evolving path. Each discovery opens new doors, revealing deeper layers of complexity and beauty within the universe. The philosophical implications of the quantum vacuum serve as a guiding light, illuminating the way forward as we navigate the intricate web of existence. What awaits us in the depths of this exploration? The answers remain elusive, yet the quest itself is a testament to the boundless curiosity of the human spirit. As we ponder the mysteries of the quantum vacuum, we find ourselves drawn into a world of wonder and possibility, where the interplay of energy and existence invites us to dream beyond the confines of our current understanding. The journey is ongoing, a continuous unfolding of revelations that will shape the future of science and philosophy alike. As we delve deeper into the realm of quantum vacuum and its philosophical implications, we encounter the captivating concept of quantum fluctuations. These fleeting phenomena remind us that even in what we perceive as empty space, a vibrant dance of energy is at play. Picture, if you will, the subtle ripples that emerge in the fabric of vacuum, each fluctuation giving birth to virtual particles that flicker into existence and vanish in an instant. This ephemeral nature leads us to ponder, if empty space is not truly empty, what does that mean for our understanding of reality? Philosophers have long grappled with the essence of existence itself, and the nature of quantum vacuum adds a layer of complexity to this exploration. The ontological status of vacuum challenges us to reconsider what it means for something to exist. Is existence solely defined by tangible matter? Or can the potential energy within the void be considered a form of reality? As physicist David Bohm noted, the universe is an undivided whole, and everything is connected. This perspective invites us to reflect on the interconnectedness of all things, urging us to see the vacuum not as mere emptiness, but as a rich source of potential that underlies the very structure of the cosmos. Imagine, then, a universe in which the vacuum is a dynamic entity, teeming with possibilities. This vision aligns with the notion that reality is not a static backdrop, but a living canvas, constantly shaped by quantum events. The paradox of empty space as a source of energy leads us to question the boundaries of our understanding. How can something that appears devoid of substance harbor such profound implications? As we come to grips with these ideas, we may find ourselves compelled to reevaluate our beliefs about existence itself. The philosophical debates surrounding quantum mechanics deepen as we consider the implications of wave-particle duality. Renowned physicist Niels Bohr famously stated, "We are all agreed that your explanation is correct, but your explanation is also irrelevant." In this statement lies a challenge to the traditional dichotomy of particle and wave, suggesting that reality may be more nuanced than we can fully comprehend. The duality observed in quantum mechanics emphasizes the intricate relationship between observer and observed, compelling us to confront the role of consciousness in shaping our experience of reality. What if our observations are not merely passive reflections of an external world, but rather active participants in the unfolding of existence? This tantalizing possibility invites us to explore the role of human perception within the quantum vacuum. The act of observation itself may alter the very fabric of reality, as hinted at by the famous double-slit experiment. When particles are observed, they behave like particles. When left to their own devices, they exhibit wave-like properties. This enigmatic behavior raises profound questions. Is reality contingent upon our awareness, or does it exist independently of our perceptions? As we ponder these intricate ideas, we are reminded of the words of Albert Einstein, who said, "The most beautiful thing we can experience is the mysterious." The mystery of the quantum vacuum invites us to embrace uncertainty and wonder, urging us to venture beyond the limitations of conventional thought. It challenges us to accept that the universe may not conform to our expectations, but rather unfold in ways that inspire awe and contemplation. Furthermore, the implications of the quantum vacuum extend beyond theoretical musings, influencing our understanding of cosmology and the very fabric of the universe. The energy fluctuations that arise in this vacuum may hold the key to unraveling the mysteries of dark energy and cosmic inflation. As we explore these connections, we must confront the significance of our place within this vast cosmos. Are we merely observers of a universe that operates according to fixed laws? Or do we play an integral role in shaping its destiny? With each question, we find ourselves venturing further into the depths of philosophical inquiry, where science and metaphysics entwine. In this rich landscape, the quantum vacuum emerges not only as a subject of scientific study, but as a profound reflection of our own existence. The interplay between reality and perception invites us to engage more deeply with the mysteries that surround us, urging us to seek understanding beyond the surface of things. As we continue this exploration, we may find that the path itself is as enlightening as the answers we seek, fostering a sense of connection to the universe that is both humbling and exhilarating. As we embrace the complexity of the quantum vacuum and its implications for our understanding of reality, we are reminded that our journey is just beginning. The questions raised about our role as observers and participants in this enigmatic landscape beckon us to delve deeper into uncharted territories of research. With emerging technologies and innovative methodologies at our disposal, the quest for experimental verification of these profound theories promises to reshape our understanding of the cosmos. In the next chapter, we will explore the cutting-edge developments in quantum vacuum studies and the interdisciplinary approaches that are paving the way for future breakthroughs, inviting us to consider how these advancements may illuminate the mysteries we have only begun to fathom. Chapter 9. Future Research Directions in Quantum Vacuum Studies. The vacuum, often perceived as a mere absence of matter, reveals itself as a source of exotic phenomena that challenges our fundamental understanding of reality. Imagine a vast, silent expanse where the fabric of space-time pulses with energy, teeming with possibilities. This realm is not just empty, it is alive with the potential for remarkable events. Quantum vacuum fluctuations, those fleeting appearances of virtual particles, give rise to intriguing scenarios. The vacuum can produce phenomena such as Hawking radiation, where black holes emit particles, hinting at a world where nothingness becomes a conduit for the extraordinary. As scientists delve deeper into the mysteries of the quantum vacuum, emerging technologies promise to reshape our exploration of these elusive concepts. Advances in nanotechnology, for example, are enabling the manipulation of materials at unprecedented scales. These developments open doors to experimental setups capable of probing vacuum properties with exquisite precision. Quantum sensors, poised to revolutionize measurement techniques, can detect minute changes in the vacuum state, offering insights into its interactions with matter. The potential for harnessing these technologies not only enhances our understanding, but might also lead to practical applications that meld theoretical insights with tangible benefits. The quest for experimental verification of theories surrounding the quantum vacuum is a journey marked by ambition and ingenuity. How do we transform abstract concepts into observable phenomena? This question fuels the passion of researchers worldwide. The challenge lies in designing experiments that can convincingly demonstrate the intricacies of quantum effects. One notable endeavor is the search for evidence of dark energy, a mysterious force believed to permeate the universe, potentially linked to vacuum energy. As physicist Brian Greene eloquently stated, "The universe is a vast, strange place, and our understanding of it is still in its infancy." This sentiment resonates deeply in the realm of vacuum studies, where theories await their moment of validation. Interdisciplinary approaches serve as a vital catalyst in advancing our understanding of quantum vacuum physics. The merging of fields like quantum mechanics, materials, science, and even philosophy enriches the dialogue surrounding these complex topics. Collaborations between theoretical physicists and experimentalists yield new insights, transforming abstract theories into concrete findings. Imagine a physicist working alongside an engineer to develop a device that could manipulate vacuum fluctuations. This synergy not only enhances our comprehension, but also nurtures creativity, allowing new ideas to emerge from the interplay of diverse perspectives. Looking ahead, predictions for future breakthroughs in quantum vacuum physics ignite the imagination. Will we uncover new forms of energy harnessed from the vacuum itself? Could the manipulation of vacuum fluctuations lead to revolutionary advancements in propulsion technologies, making interstellar travel a feasible dream? As we ponder these possibilities, we are reminded of the words of Richard Feynman. "The imagination of nature is far greater than the imagination of man." This profound statement captures the essence of our exploration. The mysteries of the vacuum may yet unveil phenomena beyond our current comprehension. Consider the implications of successfully verifying the existence of exotic vacuum states or discovering new particles born from vacuum fluctuations. Such breakthroughs could redefine our understanding of fundamental forces and the very structure of reality. The potential to manipulate vacuum energy could pave the way for revolutionary technologies, perhaps even altering the balance of energy resources on Earth. As we stand on the precipice of these scientific horizons, the journey into the quantum vacuum unfolds like a vast, uncharted ocean. Each wave of discovery beckons us to dive deeper, to explore the currents of knowledge that surge beneath the familiar surface of existence. We are left to wonder, what will we find in the depths of this enigmatic realm? What secrets does the vacuum hold, waiting patiently for us to uncover? The future of quantum vacuum studies promises to be a tapestry woven from threads of curiosity, creativity, and collaboration. As we embrace the unknown and venture forth into this new frontier, we carry with us the hope that each step will illuminate the shadows of uncertainty, guiding us toward a richer understanding of the cosmos and our place within it. The vacuum, often perceived as a mere void, is increasingly recognized as a source of exotic phenomena that challenges our conventional understanding of physics. As we delve into this multifaceted realm, we begin to encounter the extraordinary. The vacuum is not simply empty space. It is an arena teeming with potential, a stage where particles flit in and out of existence. Imagine a bustling marketplace where the ephemeral and the substantial coexist, where the very rules of engagement shift and evolve. In this context, the concept of vacuum states emerges as a focal point of inquiry. These states, characterized by their unique energy configurations, hold the promise of untapped energy sources. As physicist Steven Weinberg once remarked, "The more we learn about the universe, the more we see that we are a part of it." This interconnectedness suggests that understanding the vacuum may unlock pathways to harnessing energies that have long remained elusive. Emerging technologies are set to revolutionize vacuum research in unprecedented ways. For instance, advancements in quantum sensing and measurement techniques allow us to probe the nuances of vacuum fluctuations with a precision that was once thought unattainable. Imagine the implications of such refined measurements, where we can observe the faintest echoes of virtual particles, those transient inhabitants of the vacuum that manifest under specific conditions. The development of superconducting quantum interference devices and optomechanical sensors is poised to enhance our ability to detect these fluctuations, offering a glimpse into the hidden dynamics of the quantum vacuum. As we explore these technological frontiers, the quest for experimental verification of theories becomes paramount. How do we substantiate the predictions of quantum field theory and the existence of exotic vacuum states? A promising avenue lies in high-energy particle collisions, where conditions mimic the early universe's chaotic environment. Projects like the Large Hadron Collider are not just monumental achievements in engineering, they are gateways to unearthing the mysteries of the vacuum. The collisions create a fertile ground for the birth of new particles, offering insights into the vacuum's role in mass generation and energy dynamics. The role of interdisciplinary approaches cannot be understated in advancing our understanding of quantum vacuum phenomena. Physicists, engineers, and philosophers alike must come together, sharing their insights and methodologies to forge new paths in research. Consider the integration of quantum information theory and vacuum studies, where the principles governing information processing may reveal deeper connections with the fabric of reality. As the renowned physicist John Archibald Wheeler stated, "We are all connected, to each other biologically, to the Earth chemically, to the stars astronomically." This interconnectedness underscores the importance of collaboration across disciplines, as exploring the vacuum may yield insights that resonate within multiple fields of study. Predictions for future breakthroughs in quantum vacuum physics are both tantalizing and vast. Will we find ways to engineer vacuum states that can manipulate gravitational fields or influence the behavior of light? The potential for creating directed energy flows from vacuum fluctuations opens doors to technologies that could transform energy production and transmission. Envision a world where energy harvesting from the vacuum becomes as commonplace as tapping into solar or wind power, fundamentally altering our approach to sustainability. As we contemplate these possibilities, it is essential to consider the philosophical implications of such advancements. What does it mean for our understanding of reality if we can harness energy from what was once thought to be an emptiness? The vacuum, once perceived as a mere void, emerges as a vibrant and dynamic player in the grand narrative of existence. The questions we ask today will shape the discourse of tomorrow, inviting us to reevaluate our relationship with the cosmos. The exploration of vacuum phenomena is akin to peering into a mirror that reflects the intricate weave of the universe. Each discovery serves as a reminder of our enduring curiosity and desire to comprehend the unfathomable depths of nature. As we stand on the brink of potential breakthroughs, we must remain open to the unexpected, ready to embrace the revelations that lie ahead. In this uncharted territory, we are guided by the words of Albert Einstein, who once said, "A human being is a part of the whole called by us universe." This perspective invites us to view our quest for knowledge not as isolated endeavors, but as collective journeys that transcend individual disciplines. As we continue to dig deeper into the quantum vacuum, we enrich our understanding of the universe and our place within it. The intersection of theory and experimentation will yield new insights into the characteristics of vacuum fluctuations. What if we could observe these fluctuations not just as theoretical musings, but as tangible phenomena with practical implications? The prospect of developing technologies that manipulate vacuum states to produce coherent energy sources remains a tantalizing frontier. Imagine devices that can tap into the vacuum's energy, leading to breakthroughs in propulsion systems, energy storage, and even medical applications. As we forge ahead, the implications of our discoveries in vacuum studies will ripple through society. How might these advancements reshape our technologies, our economies, and our very understanding of the laws of nature? Will vacuum energy become a cornerstone of future power systems? Or will it serve as a catalyst for new philosophical conversations about the nature of existence itself? The journey into quantum vacuum studies is not merely a scientific endeavor. It is a profound exploration of the interconnectedness of all things. It invites us to reflect on the broader implications of our findings, to consider how our understanding of the vacuum can influence our approach to global challenges, such as climate change, energy sustainability, and technological equity. As we collectively embark on this voyage into the quantum realm, we must cherish the spirit of inquiry and wonder that drives us forward. The vacuum, with its secrets waiting to be unveiled, beckons us to explore its depths. Each question we pose leads to new avenues of investigation, and each answer we uncover opens the door to further mysteries. In this dance of discovery, we are reminded that the journey is as important as the destination. As we traverse the landscape of quantum vacuum studies, we cultivate a deeper appreciation for the unknown. The future may hold challenges, but it also brims with potential, urging us to embrace the possibilities that lie ahead. What marvels await us in the quiet whispers of the vacuum? What discoveries will illuminate our understanding of the universe and redefine our relationship with the very fabric of reality? The answers perhaps lie just beyond the horizon, waiting for the curious minds and adventurous spirits to reach out and grasp them. The exploration of the quantum vacuum is not just a scientific pursuit. It is a testament to human ingenuity and the relentless quest for knowledge that has defined our species throughout history. As we stand on the cusp of this unfolding narrative, the insights gleaned from our exploration of quantum vacuum studies illuminate not only the intricacies of the universe, but also challenge the very foundations of our understanding of reality. The implications of our findings are profound, urging us to reconsider our theoretical frameworks and to embrace the evolving nature of quantum field theories. With each discovery, the vacuum reveals itself as a new frontier in physics, inviting us to delve deeper into its mysteries. What lies ahead in this uncharted territory? In the next chapter, we will explore the key findings that redefine our approach to the quantum vacuum and the exciting challenges it poses for our understanding of the universe. As we embark on this next phase of inquiry, let us remain open to the unknown and ready to confront the revolutionary ideas that await. Chapter 10: Quantum Vacuum, a New Frontier in Physics. The quantum vacuum, often perceived as mere emptiness, is revealing itself as a profound frontier in physics, one that beckons researchers to explore its depths. The future of quantum vacuum studies is rich with potential, presenting avenues that promise to reshape our understanding of reality itself. As scientists delve deeper, they are uncovering the intricate connections between the vacuum and the fundamental forces of nature. This exploration invites us to ponder, what lies beneath this seemingly empty void? One of the most exciting prospects for future research is the development of technologies that harness quantum vacuum phenomena. Imagine the possibilities of manipulating vacuum fluctuations to achieve breakthroughs in energy efficiency or propulsion systems. As physicist Richard Feynman once remarked, the most beautiful thing we can experience is the mysterious. The mysterious nature of the quantum vacuum could very well lead to innovations that transform our technologies. Key findings in the realm of quantum vacuum studies have already begun to shift paradigms. For instance, the understanding of vacuum energy, once relegated to theoretical musings, is now finding its footing in practical applications. The implications of these findings are vast. They challenge our classical notions of space and time, urging us to reconsider the very fabric of the universe. This evolution in thought is a testament to the dynamic nature of quantum field theories. As these theories evolve, they reveal deeper truths about the universe, suggesting that our previous models may only scratch the surface of a more intricate reality. The quantum vacuum does not merely challenge our scientific frameworks, it also compels us to confront the mysteries of existence itself. What if the fabric of our universe is woven from the very fluctuations of this vacuum? The idea that empty space is alive with energy and potential is both exhilarating and unsettling. It invites us to reconsider the boundaries of knowledge. Esteemed physicist Albert Einstein famously stated, "The most incomprehensible thing about the world is that it is comprehensible." Yet, as we probe the quantum vacuum, we may find that understanding may come at the cost of embracing uncertainty. As researchers continue to explore this enigmatic frontier, they are likely to encounter questions that push the limits of human comprehension. The significance of embracing the unknown in science cannot be overstated. The journey into the quantum vacuum is not merely about uncovering facts, it is about challenging our very notions of what it means to know. The exploration of this realm requires a delicate balance between skepticism and wonder. It is an invitation to marvel at the complexities of the universe while remaining grounded in empirical inquiry. In contemplating the implications of quantum vacuum theories, we might ask ourselves, how does this knowledge alter our perception of the universe's origins? The interplay between the vacuum and cosmic phenomena suggests that what we perceive as matter and energy may be deeply intertwined with the vacuum itself. This realization leads us to consider the cosmos not as a static entity, but as a dynamic, ever-evolving tapestry of energy and potential. The ongoing evolution of quantum field theories is a testament to the collaborative spirit of science. Researchers from various disciplines are coming together, sharing insights and methodologies, and enriching the dialogue surrounding quantum vacuum studies. This interdisciplinary approach is crucial for fostering innovations that may arise from the intersection of physics, engineering, and philosophy. The potential breakthroughs that await us are limited only by our imagination and our willingness to explore the uncharted territories of knowledge. As we stand on the brink of this new frontier, we are reminded of the words of physicist Niels Bohr, who once said, "An expert is a person who has made all the mistakes that can be made in a very narrow field. Each step into the unknown carries the risk of miscalculation, yet it is this very exploration that propels us forward." The quantum vacuum challenges us to take those risks, to embrace the uncertainties that lie ahead, and to remain curious in our quest for understanding. In this dance with the unknown, we find a mirror reflecting our own existence. The mysteries that the quantum vacuum holds are not unlike the mysteries of life itself. Just as we navigate the complexities of our own experiences, we must also navigate the complexities of the universe. The journey through this vacuum invites us to reflect on our place in the cosmos, to ponder our connection to the fabric of reality, and to embrace the beauty of the questions that remain unanswered. As we consider the implications of our findings, we might wonder how these insights could influence future generations. Will they look back at our exploration of the quantum vacuum as a pivotal moment in understanding the universe? Or will they forge new paths that we cannot yet envision? The beauty of scientific inquiry lies in its ability to inspire curiosity and ignite passion within those who seek the truth. In the end, the quantum vacuum offers us more than just a playground for theoretical exploration. It extends an invitation to engage with the fundamental questions of existence. It reminds us that the universe is not a mere backdrop for our lives, but a living, breathing entity filled with mysteries waiting to be uncovered. As we embrace the unknown, we open ourselves to possibilities that can reshape our understanding of reality itself. The significance of embracing this journey cannot be overstated. It is a reminder that science is not just about answers, but also about the questions that propel us forward. As we stand at this new frontier, we are not merely observers. We are participants in a grand exploration. The quantum vacuum beckons us to dive deeper, to continue asking the questions that challenge our perceptions, and to find solace in the mysteries that surround us. The exploration of quantum vacuum continues to expand, revealing new horizons in our understanding of the universe. Emerging technologies are paving the way for profound discoveries. Imagine the immense potential of advanced quantum sensors, which harness the delicate fluctuations of the vacuum. These devices could lead to unprecedented precision in measurements, revolutionizing fields ranging from metrology to navigation. As we develop these technologies, we find ourselves standing on the precipice of a new era in scientific research. One of the most exciting avenues for future research involves the quest for experimental verification of the intricate theories surrounding quantum vacuum. Scientists are increasingly turning to high-energy particle colliders, such as the Large Hadron Collider, to probe deeper into the mysteries of vacuum energy. These colossal machines allow researchers to recreate conditions similar to those just after the Big Bang, enabling them to study the fundamental interactions that govern our universe. What secrets might lie hidden in the particles and phenomena that emerge from these collisions? The answers could reshape our understanding of fundamental forces in the very nature of reality. As we venture into this new territory, interdisciplinary approaches will play a crucial role in advancing our understanding of the quantum vacuum. The convergence of physics, mathematics, and even philosophy fosters a rich environment for innovative thinking. Consider the words of physicist Richard Feynman, who said, "The imagination of nature is far greater than the imagination of man." This sentiment resonates deeply as we draw insights from various fields, crafting a more comprehensive picture of the vacuum's role in the cosmos. The interplay between disciplines enables us to explore questions that have long lingered at the edges of scientific inquiry, inviting novel perspectives and breakthroughs. The implications of our findings extend beyond the confines of theoretical physics. The quantum vacuum challenges our conventional understanding of the universe and prompts us to reconsider long-held beliefs. What if the very essence of reality is intertwined with the fluctuations of this seemingly empty space? Such reflections invite us to contemplate the nature of existence itself. In the words of physicist Niels Bohr, "Your theory is crazy, but it's not crazy enough to be true." This playful acknowledgement of the limits of our understanding serves as a reminder to embrace the unknown, to remain open to the possibilities that lie beyond our current grasp. As we delve deeper into the quantum vacuum, we confront questions that probe the boundaries of knowledge. Could vacuum energy be the key to unlocking the mysteries of dark energy, the enigmatic force driving the accelerated expansion of the universe? The notion that empty space could be a source of immense energy invites us to reconsider our relationship with the cosmos. Imagine a future where we harness this energy sustainably, transforming our approach to energy production and consumption. The potential for such advancements is both thrilling and daunting. Moreover, the ongoing evolution of quantum field theories offers a glimpse into the dynamic nature of scientific understanding. Theories once thought to be solid foundations are now evolving, adapting to incorporate new discoveries and observations. This fluidity in our comprehension of the quantum vacuum reflects the ever-changing landscape of science itself. As physicist Albert Einstein once remarked, "The most beautiful experience we can have is the mysterious." In this dance with the unknown, we find the beauty that fuels our inquiry. The quantum vacuum also holds the promise of insights into the origins of the universe. Theories proposing connections between vacuum fluctuations and cosmic inflation suggest that the very fabric of reality emerged from this turbulent, energetic void. This notion invites us to ponder profound questions about the birth of space and time. What lay before the universe as we know it? Were there realms of potentiality waiting to be realized? The answers to such inquiries may lie in the heart of quantum vacuum studies, waiting for intrepid explorers to uncover them. As we reflect on the significance of embracing the unknown within the scientific realm, we recognize that it is not merely about accumulating knowledge. It is about the journey itself, the ongoing pursuit of understanding that ignites our curiosity and drives us forward. The quantum vacuum embodies this journey, offering a canvas upon which we can paint our theories and dreams. Each discovery acts as a brushstroke, gradually revealing a more intricate picture of the universe. In contemplating the implications of our findings, we are reminded of the words of physicist Max Planck, who stated, "Science advances one funeral at a time." This poignant observation underscores the importance of fostering new generations of thinkers and dreamers who will carry the torch of inquiry into the future. As we pass on the knowledge we have gained, we inspire a new wave of curiosity, a fresh perspective that may unlock even greater mysteries. The quantum vacuum, with its boundless potential, serves as both a challenge and an opportunity. It challenges us to confront our limitations, to question our assumptions, and to remain humble in the face of the vast unknown. Yet, it also offers the promise of discovery, of insights that could reshape our understanding of existence itself. As we continue to explore this frontier, let us remain steadfast in our commitment to inquiry, to the beauty of unanswered questions, and to the profound journey that lies ahead. In this ever-unfolding narrative of science, the quantum vacuum beckons us to engage, to dream, and to discover the wonders that await us in the depths of empty space. As we close this chapter on the quantum vacuum, we find ourselves standing at the precipice of a vast, uncharted frontier. The insights gleaned from our exploration serve not only to deepen our understanding of the universe, but also to ignite the flame of curiosity that drives future generations. Each question raised and each theory proposed is a testament to our unyielding desire to comprehend the complexities of existence. With the quantum vacuum as both our canvas and our guide, we are reminded that the journey of discovery is as significant as the answers we seek. As we move forward, let us embrace the uncertainties that lie ahead, for within them lies the promise of new revelations and the continued quest for knowledge.